Right, in this lesson we're still going to be focusing on working with mean, mode, median and range, but we're moving into grade D territory now, where we can start looking at data that has been grouped. Now, what I always suggest with any question where you're presented with information in a table is you make sure before you even think about answering the question that you understand what the question is, what the table is giving you. And to do that, you want to try and tell a story for the table, turn it into some form of sentence within the context of the question. So in this example, we're talking about weights of eggs bought in the supermarket. So the frequency table shows the weights of eggs bought in the supermarket. The top column gives you the weight in grams, so 58 grams, 59 grams. And the bottom row, sorry, not column, row, gives you the frequency, the number of eggs, 3, 7 eggs, 11 eggs, and so on. Then pick a column and try and turn that into a sentence. So this one here, this is saying there are 11 eggs which weigh 60 grams. And once you think you've got your head around that, then you can then further consider other language. So if I was to ask you the question, how many eggs were weighed at least 62 grams? So weighing at least 62 grams, well, at least means it could be more than 62 grams. So the eggs weighing at least 62 grams here would be 10. Those 8, which weigh 62, plus those 2, which weigh 63. So there would be 10 eggs that weigh at least 62 grams. So you need to, once you think you understand the context, make sure you can answer exactly what they're asking you based on the language they're using. Now, to calculate the mean, same method applies as with raw data. We want to find the total weight and the count. How many eggs are there altogether? Sometimes the count will be given in the question. They will say there are 17 eggs or 28 eggs or however many there are. Other times you have to work it out from the frequency. Now, in order to find the total, we have here, we know that there are 3 eggs that weigh 58 grams. So what we could do, just trying to find a bit of scrap paper here. So what we could do is we could say, well, those 3 are 58 and 58 and 58. Then we come to these 7 eggs which weigh 59. So adding 7 lots of those and so on. But that's not very efficient, because then I'd have to write out 60 11 times, 61 9 times, and so on. So luckily in maths we know that adding something together 3 times is the same as multiplying them together. So to find the total weight of those 3 eggs, it's 58 times 3. So those 3 eggs in total weigh 174 grams. Then I've got 7 eggs that weigh 59 grams. So in total, those would come to 413. Then 60 lots of 11, 671. 61 lots of 9, 549. 62 lots of 8, or 8 lots of 62, same thing. And 2 lots of 63, 126. So in order to find out the total weight of all the eggs, I know that those 3 weigh 174 and those 7 weigh 413. So to work out the total weight of the eggs, I'll add those together. So 174 plus 413 plus 671, 549, 496, 126 is 2,429 grams. That's what they weigh in total. So to find the mean, I need to divide that by how many eggs there are. Now the number of eggs so the count is the number of eggs, and I know there are 3 there, and 7 there, and 11 there, and 9 there. So the count is the number of eggs, which is 3, add 7, add 11, add 9, add 8, add 2. 3 and 7 is 10, 21, 30, 38, 40. So the mean is total 2429, and divide, I can write divide like a fraction. Okay, so I can write 2,429 divided by 40 like that, rather than use the arithmetic sign. You could use the arithmetic sign if you prefer. 2429 divided by 40. See, I've typed it in there with a divide, and they've turned it into that format. It doesn't matter. Then to turn that into a decimal, which might make more sense, you press the SD button, and we're going to write that to 1 decimal place. So 0.7, the next one across is less than 5, so it stays as 7. So the mean weight is 60.7. Now, a common mistake to make when calculating the mean from group data is when you divide the count, when you want to find the count, you go 1, 2, 3, 4, 5, 6. I'm going to divide by 6 because there are 6 categories. Now, if you do that, so if we do 2429 divided by 6, the answer for that mean is 404.8 grams. If you make that mistake, hopefully you're checking your answer to see, does that seem reasonable? Remember, the whole thing about averages are that they're giving you a value you could expect to get from that data. Now this data goes from 58 grams to 63 grams. So if you've got an expected egg weight of 404 grams, that should be setting off alarm bells in your head. Not as much as the chicken that would be trying to lay that size egg, but still you should be thinking, hang on, there's something wrong with that. It's way off. The biggest value is 63 grams. So then come back and think, oh yeah, it's not divided by 6, it's the number of eggs, and so on. So that's the mean. The mode, we can get that from the group data as well. Just as with raw data, it's the weight that occurs most often. So we're looking for the largest frequency, which is 11. Now a common mistake to make is to then say the mode is 11. The mode isn't 11, the mode is 60, because 11 is bigger than anything else. So the weight that occurs most often is 60 grams. And then to find the median, the data is already in order. If we go back to this, I could keep writing that out. If there are 40 eggs, I'm looking for the middle egg, so I'm looking for the sort of 20th egg. So I could list them all out and count to find what the 20th one was. But there's no need, because they're all listed here. I'm looking for the 20th egg. The 3 smallest take me to there. If I'm travelling from there to there, I've got those 3 and those 7. The 10th egg takes me to there. To get to this point, I got those 3 and those 7 and those 11, which come to 21. I'm looking for the 20th egg because I've got 40 eggs. So the 20th egg is going to be in this category. So the median 20th egg, which is in the 60 grams. Just checking through that again. This is the one that people find the trickiest to remember. First 3 are there. The first 10 are there, 7 and 3. The first 21 are to there. The next 30, or the first 30 would be to there, but I'm only looking for the 20th egg. So it's in that category, so it's got a median of 60 grams. So if we just have a practice at some now. So mean, mode and median of these. The mean, I multiply. So 49 times 2, 98, 150, 155, 520, 53 times 6, I'm not going to show off with that one, 318, and 54 times 4, 216. I want the total, so I have to add those together. So 98 plus 150, 155, 520, 318, 216, 1457. The count, well, we've got packs of butter, and it tells us there 30 supermarkets. So the count is 30, so the mean is 1457 divided by 30, .48, 1 decimal place. It's a 5 or a 6. You look across to the next one. It's bigger than 5, so that rounds to 6. The mode, which price occurs most frequently, biggest frequency there, 52 pence. And then the median, if there's 30 packs of butter, I'm looking for the 15th. So let's get a running total. It's 2 to there, it's 5 to there, 2 plus 3, it's 10 to there, 2 plus 3 plus 5, it's 20 to there, I'm looking for the 15th, so the 15th is in there between 10 and 20, which is 52 pence. So the mode is 52, the median is 52, the mean is 48.6. Doesn't ask you for the range, but if you wanted to find the range of that data, well, the highest price is 54, the lowest price is 49, so the range would be 54 take away 49, 5 pence. Question 2. A box contains 50 nails of different lengths as shown. So let's just take a look. Let's pick that column there. This is telling me that 9 nails had a length of 4 centimeters. 10 nails had a length of 6 centimeters. For the mean, I need the total, so I'm going to multiply those numbers together. 8, 21, 36, 60, 60, 7 eighths, 56. So we'll add those. 8, plus 21 plus 36 plus 60 plus 60 plus 56 is 241. The count is 50. They're telling me there are 50 nails. So the mean is 241 divided by 50. 4.8 centimeters. The mode, which length occurs the most often, one with the highest frequency, 5 centimeters. And the median, there are 50 items, 50 nails. I'm looking for the middle. I'm looking for the 25th. Get my running total going. It's 4 to there. It's 4 and 7, 11 to there. It's 11 and 9, it's 20 to there. I'm looking for the 25th. It's 32 to there. The 25th is in there between the 20th nail and the 32nd nail. So the median is 5 centimeters. So I got a mean of 4.8, a mode of 5, and a median of 5. And then the final example. The following marks were scored by pupils in a maths test. So the mark between 0 and 6 and the number of times pupils scored it. So that one there is telling me there were 8 pupils who scored 2 in the maths test. To find the total, we're going to multiply. Now a common mistake here is to write 0 threes is 3. 3 lots of 0 is 0. No matter how many lots of 0 you've got, you end up with nothing. 1 5 is 5, 2 8s is 16, 27, 5 4s are 20, 5 7s are 35, 3 6s are 18. I need to add those together to get my total. So 5 plus 16 plus 27 plus 20 plus 35 plus 18, 121. Count. Well, in this example, it's not telling me how many kids there are. So I've got to add up the frequency now. There are 3 there, and 5, and 8, and 9, and 5, and 7, and 3. So 3 plus 5 plus 8 plus 9 plus 5 plus 7 plus 3. 40 pupils. So the mean will be 121 divided by 40. Which is 3.0. 1 decimal place, look at the next one, is less than 5, so it stays as 3.0. The mode would be the one that occurs the most. 3 occurs the most, it occurs 9 times. And then the median will be the 20th, because I got 40 kids, the 20th piece of data. Get my running total going. 3 and 5 is 8, 3 and 5 is 8, and 8 is 16. 16 to there, and another 9 is 25. I'm looking for the 20th, so it's going to be in there. So the median is 3. So there you go. That's dealing with data that has been grouped. That type of question, you're looking at grade E, grade D level of challenge.